Welcome back to the series on functional programming. In the last video, we talked about the principles of functional programming, which we'll be using as our series template. But before we get into it, hey, stop it. Before we get into it, I want to go over two quick things that we'll be using throughout the rest of the series. This will be a quick crash course in writing tests for Jest and using generics in Typescript. If you're already familiar with these two things, feel free to skip to the next one, or stick around and hang out with me because doing friendship is fun.
F is for friends who do stuff together.
Either way, subscribe and hit that bell so you don't miss the next one. Now, let's get into it. For real this time. If you're not already sold on testing, it's one of the most important parts of software development. It helps you be sure that the code you're writing is actually doing what you think it's doing, which is important especially when you make large changes to your code base and want to make sure you're not breaking something over here while you're working on something over here. In my opinion, if you can write code that's very easy to test, it means you've designed it very well. And that's one place where functional programming really shines. Per the principle of purity from the last episode, every function in functional programming takes its input and returns some output. Its output only depends on the input that you give it. And composing multiple functions together gives you a whole program, which is just another function that takes some input and returns some output. This makes it very easy to test because you give it some input and make sure it gives you the output that you expect. For example, if you have a function to grade the students in a class, you can give it some minimal input like a few made-up students and a few made-up project and test grades, for which you can manually figure out what the answer should be and test that your function actually returns that value. Throughout the series, I'll be using tests to show off all the functions because it's very easy to see how they work when you see an input and an output. Let's look at a simpler example in code so we can see what that syntax looks like. Here in this test file, we have a describe block, which is basically just a grouping of whatever you want it to be. You can give it the name of a function, the name of some test cases, whatever. In this series, we'll purely use these as logical groupings. Most importantly, this it function describes an actual scenario to test. You give it the name of the scenario and write some code inside it, which will run some assertions. The name of this test, works, is actually pretty lazy, but I'll be using it a lot over the series because most of the time we'll just be using one test to understand what a function is doing. The say hello function is what we're testing, and we'll call it with some input, in this case, the string world. We'll save the output of that function to a variable called result. And then the actual assertion happens here, where we expect that result equals this output. In this case, hello world. This testing framework, Jest, comes with other assertions that you can run, which are called matchers. We can test that some array ABC contains a particular value, A. Or we can test that two numbers are close enough. Most of the tests in this series will just use exact equality, and that's all you really need to know. I guess sometimes I'll use the function called test instead of the function called it, and that's purely for my neuroses so it reads grammatically correctly. It works, and test doing other stuff. Other than that, it makes no difference. And as you see here, sometimes I'll define a function within a test itself, and sometimes I'll just call that function directly inside the expect instead of saving it to a variable first. It's just what I happen to feel like writing for what I thought would be most readable. Okay, moving on to generics in TypeScript. These let you write functions that can work on many different types of inputs. For example, let's say we have a function that concatenates two arrays. We want to return a new array with all elements of the first one followed by all elements of the second one. We could write it like this, taking two arguments, each with a type of string array. In this test, we can see how it works. Of course, if we give it an array AB, an array CD, it will return us A, B, C, D. Great. But because we specifically wrote this function for arrays of strings, if we try to pass it two arrays with numbers, Typescript will give us an error saying, I can't handle this. Which, fine, let's just write another function that handles two arrays of numbers. This is of course pretty annoying because it does the same exact thing as our string array function. Because we don't really care what's inside the arrays, the way that we join them is the same regardless of the data inside them. This new function works on numbers as we expect, but if we were to run it on strings, it would have the same error as before. We could take advantage of the unknown type in TypeScript, which says, I don't really know what this is, I don't really care, give me any type of variable. And here we're saying we want an unknown array, which means it should be an array of whatever, I don't care. And it looks like we solved it. This function works on arrays of numbers and arrays of strings. But obviously this doesn't solve everything, otherwise where are the generics that we're supposed to be talking about? The problem is we lose type information. When we pass it two arrays of numbers, we get a result back, and it's an array of numbers. We know that, but TypeScript has lost that information because now it just thinks it's an unknown array. Because our function accepted arrays of unknowns, it returned an array of unknowns. So TypeScript doesn't know what we have anymore. You can see this here where we try to total up all the numbers in our resulting array. TypeScript doesn't let us use the plus operator because, hey, we can't just add any old thing, you have to add numbers. Also with this solution, we can concatenate an array of numbers with an array of strings, which may or may not be what we want depending on our use case. So of course, that's where generics come in. This time, let's write the function with the generic type parameter a. This is saying, I don't know what a is, I don't really care, as long as the first and second arguments are arrays of that same type a. And because we've written it this way, TypeScript is now smart enough to know whatever we return is an array of a. And if we want, we can add an explicit return type to reflect this. This isn't necessary, but it's sometimes nice for documentation so you can see right there what type your function is returning. And now we've pretty much solved it. Our function works on two arrays of strings or two arrays of numbers. It'll also give us a type error if we try to mix an array of numbers with an array of strings. Of course, there are some ways around that. At the call site, you can explicitly set that type A to number or string. This allows us to mix and match types because an array of numbers is an array of numbers or strings, and an array of strings is also an array of numbers or strings. This being a quick crash course, I won't go into too much detail here, but let me know if you're interested in more in the comments. And lastly, with this new function, we don't lose type information anymore. You can see here that we are able to total up the array because it still knows we have numbers. And as a bonus, if we did want this function to handle a mix of types, here's one way we could do it. Instead of having a single type parameter a, we can add a second one, b. Now our first argument is an array of a's, and our second argument is an array of b's. What we return is an array of a or b's. Everything works exactly the same, except when we mix and match types, we no longer need to coerce it because TypeScript can figure out from the arguments that we have strings and numbers, and the resulting array will be an array of string or numbers. Okay, so a few notes specific to functional programming conventions compared to more general TypeScript conventions. You'll notice that we've been using letters A and B for our type parameters, where a lot of more general TypeScript uses the parameter T, sometimes U. And I think this is because of the math influence and the way functions in functional programming are written usually very generically for many different types. So the assumption is we're using generics a lot, so there's no reason to use T to indicate type because, of course, it's a type. We might as well just start at the beginning of the alphabet and use all the letters going forward. Why start at T when you could just start at A? The other quick thing you might have noticed is that last function we wrote is called concat_w. The W stands for widen, aka widening the types. The inputs to our function are an array of specifically A's and an array of specifically B's. The output type is an array where the elements are A or B. We've kind of loosened the constraint on the types, aka widened it. These little conventional terms will come out throughout the series, so I'll try to call them out whenever they get introduced for the first time. So with that crash course, we're equipped and ready to get into the next episode where we'll tackle the first principle of functional programming, purity. So hang tight, and I'll see you then.